Hi there guys. Right, last time we left you with this wonderful piece of code, um, which did this, displayed hello world, press any key to continue, and we press a key, and it displayed the result basically. Okay, so, what we are going to do, if you remember I said that we're going to stop using interrupt 21, and we were going to be using something a little bit different. So, say goodbye to all of that. Okay, so here's a new concept. We had a discussion, a brief mentioning of labels on the first couple of tutorials, and they look a little bit something like this. And then we could do this and so on and so forth. And if you remember, I said we could also do something along these lines. So you don't need the colon, and it will just allow you to put it all on one line. What we're going to do now, if you're familiar with the other programming languages such as C, C++, Java, you'll know that they always define a main function. This is what I'm going to do. Define main. You'll see why in a minute. And all I'm going to do is at the top there, I'm just going to jump to main with the underscore. Okay. While I'm at it, I'm going to save this as test 3. Now, because DOS interrupts, if you like, wraps things up for you, we are going to need to do this a little bit differently. Okay, and what we're going to use is interrupt 10. I'll just bring up interrupt 10. Here we are. Interrupt 10. And there's a whole host of information you can scroll down to. But the one we're looking at is 0EH video teletype output. And you will see that there is several parameters. We're working on a character level on this particular function. We're working with page numbers and foreground colours and all the rest of it. Incidentally, the foreground colour, because we're not in graphic mode, won't really matter. Page number will just be 0 for this particular exercise. So what we can do is start looking at what we need to add. Okay, so we know the interrupt is going to be interrupt 10. As I said, we still need the interrupt 20H because that's what exits the application. We know that we need to move into AH 0EH because that's what it says there. We know that in BH and BL we don't really care about. just as good practice, I'm going to move 0 into it. Remember I said that each register, AX, BX, CX and DX, they're 16-bit registers, they've each got individual addressable 8-bit registers, namely BH, BL, AH, AL. You can assign, as I have with this top one, an 8-bit value, or you can just assign, it's the same as doing this, but you know, it's shorthand if you like. So we're just going to move 0 into BX, which makes BH and BL both zeros. Okay, now one thing we're going to need to change is our BIOS output doesn't require the dollar terminator. Instead what we're going to use is 0. And it doesn't require that to be to terminate it, but you'll see why we're going to use that in a minute. Okay, so we basically need to move a character into AL. And as before, we've just moved text. I'm just going to try and compile that a second. And you'll see it says value out of range. That's because we're trying to move a huge amount of data into a single character, and it doesn't like it. So you may ask yourself, well, how do I move basically this text into there? The bracket approach compiles, and if I run test3, you'll see it will display the first character. What that basically does is it says, rather than get the contents, if you put it in brackets it gets the address. So what I'm doing effectively here is I am moving the first character or the first address of text into AL, which is effectively the same, if you're familiar with C, the same as indexing the first character in the array. Now of course we've got more than one character to display. We've got several, and we've got a null terminator, so how do we do that? Well, the easiest way of doing that is to use a function called loadsb. That is LODSB, and that stands for load string byte. So what we're doing is we're loading a string byte into one of the registers, and then it does a little bit of background work for us. If we look at the description, which is this says if df, which is the direction flag, which is a flag that you can set with an assembler, it's always set to 0, we haven't changed it. AL, which if you remember is where our character is equal to SI++. So what that is effectively doing is it's saying move SI into AL and then add SI1. And that is basically what loadsb does, load string byte. So rather than using this here, what we can do is we can just say load SB. And then once we've done that, we can then just call the interrupt and off we go. Now of course, one thing as some of you will notice, I forgot to actually, well I haven't forgotten, I haven't got around to actually loading the text into anything yet. So what we have to do obviously is, because load SB, as you can see from here, increments the SI, which is the source index pointer. So what we do is we move into SI text. Okay, let's see what that does. Let's compile, which is good, and we'll run it. Now we've still got a H. Why have we still got a H? Well, the reason is we need to put in a loop, which is where these labels come in handy. So how do we loop? Well, it's actually very simple. What we need to do is we need to effectively, once we've loaded in the string byte, so we've incremented the source index, it's loaded into AL, we need to basically say, does AL equal 0? If it equals 0, we've reached the end. If we haven't hit 0, we've still got more characters, so we need to carry on printing. Okay. Now, of course, because I'm doing all of this beforehand, what I'm going to do is I'm going to create a print label. That's right. Okay. So what we want to do is we want to see if AL is equal to 0. And the way we do it is with CMP, which is the compare, and we're comparing AL with 0. So that basically says, does AL equal 0? If it does, carry on. If it doesn't, go back to print. So what we are now doing is we need to jump out of here. So what we need to do is create a done label. So we call a function JE, which is jump if equal, and that basically says the last operation, which was compare AL to 0, did AL equal 0? If it did, we'll go to done. If it didn't, we'll go to interrupt 10H, and then we will jump to print. Okay. And of course I forgot the underscore again. So now if we run it, you will get the full hello world string. Problem is, we have just printed out one string. We've got another two to print out. This is a lot of work for just one string. So what I'm going to do is I'm going to split this up into effectively functions. Okay, so I'm going to call this function, I'm going to split it up, so when we call it, it does the same as this, it just does it a little bit differently. Okay, so first of all I'm going to define a label called print underscore screen. Okay, now print screen. What do I want print screen to do? I'm going to start indenting as well, just so it looks a little bit cleaner. Well, basically we can take these two lines of code, cut that, we can paste them in there. Because this is the only time we're going to want this to do this. Okay. Then what we're going to need to do is we're going to need to set up another variable, label, which says, do we have more to print, or do we have anything to print? And this will indent that, load SB. So this will load the string byte. Okay. Now we need to compare AL 0. This is all done here, guys. We've done this before. And then what I'm going to do is I'm going to say, if it's alright, we'll jump to the done label. Otherwise, we'll do interrupt 10H. It will jump to more to print, not forgetting the dot. Okay, so now what we're going to do is we're going to create the done label. And whenever you define a function in C or C++ or Java or something, you always have a return value, generally, unless it's a void. So in assembler we've got the same, just called ret, which just means return. Okay, so basically what we've just done is we've just taken all of this and made it so we don't have to worry about repetitive typing. So now if I move into source index, text, and I call screen, and then compile, you'll see it's done exactly the same as what the previous example did. But now, what I can do is this. Now, of course, we need to zero terminate these. Okay. So all we're doing is we're moving the 3 text memory addresses into SI and then calling this function. And there you have it. The same as where we left off. Okay, well, almost the same. There is one thing missing, which is getting the character from the user. Now, we've moved away from the DOS interrupts, 21, and now we have to look at alternate interrupts, such as 10 for printing. Well, the one for getting keyboard input is interrupt 16. And you'll see here keyboard gets stroke, check for keystroke, etc. etc. 0, this will give you the BIOS scan code and the ASCII character returned. So get stroke AH0. So what we're going to do is, I'm sure you can guess by now, AH00 16H, compile, and when we run, no echo. What I am going to do, however, is just to keep up with the function part of that, I'm going to create a new function called get character, and it's literally going to do, move 0, 0 and interrupt 16H and return. So these lines gets replaced with call get character, compile, run. Oh yes, it does the same. Now, what happens if you want to print the character that came back? Well, we already know that we returned AL and DL. So if we go back to our interrupt list and click on 10 and scroll down and click on 0EH again, we know that the character we want to write is an AL. So that should be fairly straightforward, as we've practically already done it. The only thing we've got is we've done a repetitive loop, so again, just to make it easier, I'm going to create a new function called print character, and we are going to move AH, 0EH, move BX 0, box, and then I am going to call interrupt 21H and return. And right down the bottom, I'm going to call print character. Compile, 2 passes, 105 bytes done. Run it up, hit the S, lowercase s. That's not worked. Why has that not worked? I am an idiot. I've called 21H. Sorry. It is 10 past 2 in the morning. I really shouldn't be doing videos at this time in the morning. Test 3, lowercase s. There you go. So this, effectively, is how we turn something like all of those DOS interrupt calls into BIOS calls. Now you may be wondering why I've shown you this. The main reason is a lot of people learn assembly language to have a go at creating their own operating systems. Well, obviously, if you've got your own operating system, Windows/DOS, interrupt functions don't work. And you'll find that out the hard way. So what this is, effectively, is it's a very beginner's guide of how you would go about displaying text and getting user inputs on your own operating system. Now, what I didn't explain earlier was because, well, we didn't have any functions, is this jump to main basically bypasses all of this, all of these, and jumps straight into the main code. But what it does is it loads this code into memory. So when you call print screen, get character, print character, it knows where they are because it's already loaded those values into memory. Well, I hope this has been of some use to you guys. Any questions, drop us a comment. I'll see you next time.